In this video, we'll be discussing how to quantify and evaluate data after running a kit on the MS instrument. Quantification of kit data is performed directly inside WebIDQ. All MS data is uploaded, converted, and stored in the WebIDQ database. Once stored, data can be directly loaded to check peak integration or re-evaluate it at a later time. To begin, we'll start with processing the LC data. Processing LC data is required for any kits with an LC-MS component, such as the P180, P400, Quant500, Quant500 XL, or bioacid kits. If LC data has not been previously uploaded to WebIDQ, open the Windows File Explorer and navigate to the folder containing the kit MS data. Select and drag all the kit MS data and drop it in the quantification window. After all the files are uploaded, the corresponding plate run is shown. If the data was previously imported, the data can be accessed by clicking the Select Plate Run to load the MS data from the database. When integrating an LC dataset, there are 4 subpanels within the Integration section. The Wells section allows you to select which sample well you want to look at. The Metabolite section allows you to view a metabolite from the selected well or wells. The RT Details shows you the highest point in the chromatogram for each of the retention time windows selected, which should usually correspond to the peak. And finally, the Chromatograms panel shows you the extracted ion chromatogram for the selected analyte of the selected wells. If you want to view multiple chromatograms overlaid on top of one another, set the slider to All and then select multiple wells from the well list. Otherwise, in the default view, the chromatogram will be shown for the selected analyte with the internal standard underneath. Before the calculation of concentrations, LC kit data needs to be integrated. First, retention time windows for each metabolite need to be defined. WebIDQ contains tools for automatically determining the retention times of each metabolite. Once all the data is loaded, make sure that a sample and metabolite are selected, and then choose one of the auto peak picking options from the drop-down menu. Choosing auto peak picking for defaults will set the same default retention time ranges for each sample based on the quality controls. Choosing just auto peak picking will apply custom retention times for each metabolite in every sample. For this example, we'll use the default peak picking since the retention time drift is low. A warning may pop up that you're about to overwrite the default retention time settings. When the automated peak picking finishes, a purple bar next to the samples indicates that WebIDQ couldn't find a peak or has low confidence about the current pick. Choose a sample and scroll through the metabolite list and update any metabolites where the retention time was incorrect. You can define or modify a retention time range by clicking once on either side of the peak. It is generally a good practice to quickly cycle through all the metabolites to make sure that everything was integrated correctly. You can quickly move through the metabolite list by using the left and right arrow keys on the keyboard. The up and down arrow keys will cycle through samples. If you're ever uncertain about which peak to choose, you can check the respective kit user manual for more information. Once you have made all the adjustments, you can click Apply to Plate Run, and these updated retention times from the selected sample will be applied to the rest of the samples. You can see that all the samples will turn blue, indicating that they are using the default retention times. If you want these retention time settings to be automatically applied to the next plate run that you import, you can click Apply as Default. If you need to make a custom adjustment that only affects one or more samples individually, you can select these samples and make the change. Afterward, the blue color will disappear, indicating that these samples have customized integration ranges. Even if you click Apply to Plate Run again from a different sample, these custom integration ranges will not be changed. To remove all custom integrations and reapply the default settings, you can click Discard Settings at the top of the screen. You can also export the integration windows of the currently selected sample by clicking the Export Integration Windows button at the top of the screen. This will save a CSV file to your PC that can be imported at a future time by clicking the Import RTs button. Importing the integration windows from a CSV file will replace all the integration windows of the currently selected samples. Keep in mind that integration windows which were defined manually for one sample are not replaced. Once all of the retention times have been updated for every sample, you can click the Integrate button to perform the integration procedure. Once the integration finishes, you can move on to the calibration section. Calibration parameters of the 7-point calibrated metabolites are shown and can be checked or adjusted in this calibration section. At the top of the screen, you can define the regression type and weighting for all the calibration curves of the selected metabolites of the plate run. In most cases, the recommended curve type is quadratic with a 1/x weighting. Select a metabolite from the left side panel and the corresponding calibration curve, calibration equation, and coefficient of determination are shown. To exclude a particular calibration point, you can either click on a calibration level in the calibration curve graphic, or you can disable the calibration level by deactivating the toggle switch on the right-hand side. To quickly exclude a calibration standard level for multiple metabolites, select all desired metabolites from the left-hand side table, then deactivate the All Metabolites toggle. The well positions and accuracies of the calibration standards and QCs are shown in the two rightmost tables. You can click on any of these samples to show the corresponding chromatograms. If required, you can readjust the integration in the chromatogram panel and then click the Reintegrate button. Check each metabolite calibration curve and make adjustments as necessary. The corresponding QC sample accuracies can be seen and updated in real time to find the best fit to represent the sample data. To start the calibration procedure of the selected plate run, click the Calibrate button. The final section of the quantification part is the validation section. In this section, you can assess the performance of the kit plate. Click Validate and wait until the procedure is completed. Within the validation section, the following features are available. The plate run will show the barcode of the current plate run. You can click on this to load the corresponding data directly into the results section. The run time will show the date that the MS data was uploaded. Plate validation will show the status of the validation. OK indicates that the plate successfully passed the validation criteria. Not OK indicates that the plate run did not meet all of the validation criteria. You can review the Analyte results window to see what the issues were and if they require being addressed. You can click on Note to open a summary of all validation notes, including a summary of all excluded metabolites or wells. To evaluate the plate run, select the sample by clicking on the corresponding well in the plate view. Validation results are displayed in the two tables, Analyte results and internal standard results. Starting with the blank sample, WebIDQ checks to make sure that there is no internal standard detected above a certain threshold, which would indicate either instrument contamination or cross-contamination of wells. In the zero samples, WebIDQ checks to make sure that internal standard is detected and then uses the Analyte concentrations to calculate the limit of detection. In the calibration standards, WebIDQ again checks for the presence of internal standard and then calculates the accuracy of each of the 7 calibration levels. In the quality control samples, WebIDQ can now calculate the coefficient of variation provided the QC was run in at least 3 replicates. Finally, for the study samples, since WebIDQ doesn't know what to expect in these samples, it simply checks for the presence of internal standards to determine if the well was prepared and run correctly. Looking at the Analyte results in more detail, in the graphics, CVs are shown as bullet points and accuracies are represented as crosses. The acceptable accuracy and CV ranges are shown in the corresponding color of the bullet points or crosses on the graphic. By clicking on a metabolite or internal standard in the list, you can look at the corresponding chromatogram to make sure that everything was integrated correctly. If you do need to make an integration change, you'll need to go back to the integration section and then reintegrate and recalibrate the plate. Internal standard intensities are shown as crosses in the internal standard section. If a sample or metabolite did not pass the validation criteria and you want to completely remove it from the validation, right-click on the metabolite and select Exclude. From the Exclude Measurements window, you can choose to either exclude the entire plate run, the selected well or multiple wells, or a specific measurement from a single well or multiple wells. Whatever the case, you'll need to activate the Exclude toggle, select what needs to be excluded from the drop-down menus, and then enter a note. Finally, click Save and then revalidate the plate. Processing FIA data is more straightforward than the LC part. If FIA data has not been previously uploaded to WebIDQ, open the Windows File Explorer and again drag the corresponding data into the quantification window. Wait until all the files are uploaded and then the corresponding plate run is shown. If the data was previously imported, the stored data can be accessed by clicking the Select Plate Run drop-down menu to load the MS data from the database. Once the data is loaded, select a representative sample or multiple samples from the well list, such as the QC2. Click on either side of the FIA feature to define the integration window. Click Integrate and wait for the process to finish. Once finished, you can go directly to the validation section and validate the plate. The process for evaluating the FIA data is the same as the LC part, so we won't go into it in more detail here. If you're running a Quant 500 Excel kit, you can import the Excel data and process it in the exact same way as the FIA data. Upload the Excel data by dragging it into the Quantification window. Choose the integration ranges and integrate the samples. Once completed, go to the validation section and validate the plate. Once all of your raw data for the experiment has been uploaded, integrated, and validated, you're ready to move on to the results section. Please make sure to review the WebIDQ user manual for more detailed information and examples. In the next section, we'll be looking at how to load data into the results and export it for further analysis.